Hello and welcome to the MAML Manual. I'm Sebastien.
And I'm Iris.
And today we'll be covering 9 problems from Meet number 5, topic number 1, Algebraic Fractions with Factoring. Without further ado, let's jump right into it. So at this point in the year, we've done a lot with factoring quadratics. However, because this topic is called Algebraic Fractions with Factoring, I only think it's fitting that we cover how to factor quadratics once more. Now, when the leading coefficient, or a, is equal to 1, it's a pretty basic process. When a is not 1, it's a little bit more complex, and I will show you 2 methods on how to factor those quadratics. But for now, let's get started with these examples. So for this first one, x squared minus 6x plus 8, well, the question is, what 2 numbers multiply to 8 and add to negative 6? So for me, personally, I love to set up a factor x. So I set it up like this, and I say we need 2 numbers that multiply to 8 and add to negative 6, and those 2 numbers would be negative 4 and negative 2. So when the leading coefficient of 1, that's as simple as putting these numbers into parentheses with x's in them. So it's going to be x minus 4 times x minus 2. And that is going to be our factored form of the quadratic. Now, it's important to know that in this case, we're not saying that this equals 0, okay? So we're not going to say that x equals 4 or x equals 2, because this is just an expression, not an equation. That's how we're going to leave our answer. So coming over here, let's do the same process for this one. So we need 2 numbers that multiply to negative 21 and add to 4. So again, let's make our factor x. We multiply to negative 21. We add to positive 4. So those 2 numbers are going to be positive 7 and negative 3. So again, when the leading coefficient is 1, it's as easy as taking these numbers and putting them into parentheses with x's. So it's going to be x plus 7 times x minus 3, and that will be our final answer, the factored version of this quadratic. Now that we've reviewed how to factor quadratics with a leading coefficient of 1, let's review how to factor quadratics with a leading coefficient greater than 1. Alright, so here are 2 examples of factoring quadratics when a is greater than 1. So for this one, I'll use our more familiar method, which is called factoring by grouping. And for this one, I'll use a method that I learned recently, which is called slide and divide. Now, it's important to know that both of the methods would work on both of these quadratics. I'm just choosing to do factoring by grouping on this one, and I'm choosing to do slide and divide with this one. So first, let's factor by grouping. So again, it's going to be a similar process where we want to find 2 numbers that multiply to something and 2 numbers that add to something. But instead of just being 8, it's going to be 3 times 8, which is 24. So our 2 numbers must multiply to 24 and add to negative 10. So that's going to be negative 6 and negative 4. So now we factor by grouping, so it's 3x squared minus 6x minus 4x plus 8. Then we can pull out a common factor from the first 2 terms, and that common factor is going to be 3x. So here it's going to be 3x times x minus 2. And then over here, the common factor is negative 4, so it would be minus 4 times x minus 2. Now, it's important to know that factoring by grouping only works if these 2 factors are the same. So x minus 2, that is the same. If these were different, then you did something wrong in the earlier process. But because these are the same, we can now say that this is 3x minus 4 times x minus 2, and that is our final answer. Again, if this were set equal to 0, then we would say x is equal to 4/3 or x is equal to 2, but because we just have an expression, we're going to just leave it in this factored form, and that's the final answer. Okay, so that was factoring by grouping. Let's come over here and do the slide and divide method, which is probably new to most of you watching. So the slide part of this is that we are going to slide the 12 over to this side and multiply it to the negative 6. So we are going to make it into a quadratic with a leading coefficient of 1. So let's go ahead and do that. So this turns into x squared plus x minus 72, because the 12 times the negative 6 is the negative 72. From that point, let's factor this quadratic, which is an easier process than factoring a quadratic with a leading coefficient that's not 1. So this one, we need 2 numbers that multiply to negative 72 and add to 1. So that's going to be positive 9 and negative 8. So that would be x plus 9 times x minus 8. Now, here comes the divide part. You need to take these constant terms and divide them by your original leading coefficient. So we need to divide 9 by 12 and divide negative 8 by 12. So when we do that, we get x plus 9 over 12 times x minus 8 over 12. Now we need to make sure that these fractions are in simplest form, okay? 9 over 12, not in simplest form. 8 over 12, not in simplest form. So this becomes x plus 3 over 4 times x minus 2 over 3. And now that they are in simplest form, we can go back to sliding to finish our factoring. So we can slide this 4 back in front of the x, and we can slide this 3 back in front of the x. So we are going to get 4x plus 3 times 3x minus 2, and that is our final answer. It is our quadratic, now in factored form. So that was slide and divide. This is factoring by grouping. It doesn't matter which way you do it. Just pick the one that is most efficient for you and makes most sense for you, and you'll be all set, because both of them work, and really it's just a matter of personal preference. Now that we've reviewed how to factor quadratics, both with the leading coefficient of 1 and greater, let's now shift our focus into the actual problems. All right, so let's express the following as a single fraction in simplest form. So notice how here we have a numerator and then a denominator, which itself is a term, plus a numerator over a denominator, which itself is a term plus a numerator over a denominator. So there's a lot going on here, and we actually would call this a continued fraction, and because it stops, it's called a finite continued fraction. Now, you don't actually need to know that it's called a finite continued fraction, but what's cool about continued fractions is that there are other ways to express numbers like e or pi. Now, if you're interested in that, I totally encourage you to research that on your own, but that's just a little math trivia fact that's not really relevant to solving this problem. So let's get back to this problem. Let's start from the bottom and work our way up. So here, 2 plus 1 over x plus 2, well, we're going to need a common denominator. So let's multiply the 2 by x plus 2 over x plus 2, and then we're adding that to 1 over x plus 2. Now 2 times x plus 2 ends up being 2x plus 4, and then we have over x plus 2 plus 1 over x plus 2, and that would equal 2x plus 5 over x plus 2. So now we've changed this to be 2x plus 5 over x plus 2, and we have 1 divided by 2x plus 5 over x plus 2, so we're just going to flip it. So now we have the expression 1 over x plus, and then this but flipped, so it's x plus 2 over 2x plus 5. Now again, we're going to need a common denominator, so we need to multiply x by 2x plus 5 over 2x plus 5, and we end up getting 2x squared plus 5x over 2x plus 5, and then we need to add this one. So down here we have 2x squared plus 5x over 2x plus 5 plus x plus 2 over 2x plus 5, and that would equal 2x squared plus 6x plus 2 over 2x plus 5. Now the last step, remember, this is still the denominator with the numerator being 1. So 1 divided by this fraction over here is just this fraction flipped. So our final answer would be 2x plus 5 over 2x squared plus 6x plus 2. And that is our final answer. Now it is important to note that we need to express our answer in simplest form. So if the numerator and the denominator share any common factors, we need to get rid of them. Now this is in simplest form. The numerator and denominator don't share any common factors, but it's important that we check that for each problem. All right, let's go ahead and move on to our second problem of the video. All right, so here's another one that we need to simplify. Now, remember, dividing by a fraction is the same thing as multiplying by the reciprocal of that fraction. So immediately, I'm going to rewrite this problem as x to the fourth plus 2x cubed plus x squared over 4 multiplied by 6 over 2x cubed plus 3x squared plus x. So let's go ahead and simplify these expressions in terms of x. So I'm going to come up here and do this one first. So we have x to the fourth plus 2x cubed plus x squared. Well, of course, an x squared can come out of that. So it's going to be x squared times x squared plus 2x plus 1. And notice that x squared plus 2x plus 1 is a perfect square. That's actually going to be x plus 1 squared. So the final factored version of that numerator is going to be x squared times x plus 1 times x plus 1. So now we have that. Now let's go ahead and factor this denominator here. So 2x cubed plus 3x squared plus x. Well, of course, we can pull out an x from that, and we're left with 2x squared plus 3x plus 1. Okay, and now let's do factoring by grouping for this one. So we can have our factor x. They need to multiply to 2, add to 3. That's pretty basic. That's just 2 and 1. So it ends up being 2x squared plus 2x plus x plus 1. And that ends up being 2x times x plus 1 plus 1 times x plus 1. So the factored version of all of this, remember we have an x originally, and then we're going to have a 2x plus 1, and then we're going to have an x plus 1. So that's the factored version of this denominator. So let's go ahead and write all of what we just did over here. So it's going to be x squared times x plus 1 times x plus 1 over 4 times 6 over x times 2x plus 1 times x plus 1. Now let's do some simplification. I noticed that an x plus 1 cancels from here, cancels from here. I also noticed that we have an x squared and an x, so we can get rid of this x and decrease this power from 2 to 1. And then finally, I noticed with 4 and 6, we can factor out a 2 from both of those, so I can make this into a 2, and I can make this one into a 3. So now let's go ahead and put this all into one fraction, and then that fraction is going to be in factored form, so we're going to have to expand it, because it tells us we want it as a single fraction, but we want no parentheses. So let's go ahead and do that. Here we have 3x times x plus 1, and then on the denominator we have 2 times 2x plus 1. So now expanding that will get us our final answer. So we will say this is equal to 3x squared plus 3x, and then divided by 4x plus 2. So that is our final answer. And again, this is in simplest form. It's a single fraction, and it doesn't have any parentheses, meaning that we expanded it from factored form. All right, let's go ahead and move on to our final three-pointer of this video. All right, so here's our last three-pointer of the video. Now we have to simplify this expression, and of course, in order to do that, we're going to need a common denominator. Now the key part of this problem is noticing that x plus 3 multiplied by 2x plus 1 gets you 2x squared plus 7x plus 3. Now just to confirm that's true, let's go ahead and do x plus 3 times 2x plus 1, and that gets us a 2x squared plus an x plus 6x plus 3, and that equals 2x squared plus 7x plus 3. So we've confirmed that that's true. So in order to get a common denominator, all we need to do is multiply this one by 2x plus 1 over 2x plus 1, and multiply this term by x plus 3 over x plus 3. So let's go ahead and do that. So we have 3 times 2x plus 1 over x plus 3 times 2x plus 1. And then we have 2 times x plus 3 over 2x plus 1 times x plus 3. And then finally we have minus 6x plus 8 over, and then of course this one is 2x plus 1 times x plus 3. So now that we have a common denominator, let's go ahead and do some simplification. Well, up here we have 6x plus 3 over x plus 3 times 2x plus 1. Here we have 2x plus 6 over 2x plus 1 times x plus 3. And then here we have minus 6x plus 8 over 2x plus 1 times x plus 3. So now combining these all together, let's start with the x's. 6x plus 2x minus 6x is just 2x. So we have 2x And then we have a 3 plus 6 minus 8, which is equal to positive 1. And then the denominator stays the same, so it's x plus 3 over 2x plus 1. Now notice, we're not done with the problem because when we did that simplification, on the numerator, we got 2x plus 1, and on the denominator, we have a factor of 2x plus 1. So those can actually cancel, and our final answer, we can write up here, is going to be 1 over x plus 3. And that is our final answer. So just to reiterate, you've got to be careful there. Once you've found your common denominator, once you get your expression, you have to check, are there any common factors remaining? In this problem, there were. The 2x plus 1s can cancel, getting us to our final answer. Let's jump into our 4 pointers for this video. All right, so here we have this problem, and now this problem is pretty intense. We have 6 quadratics, all of which need factoring. Now, of course, in these simplification problems, you will always look to find a common denominator. So let's start with those denominators. So the 2x squared minus 5x minus 3, we can set up our factor x. We need to multiply to negative 6, add to negative 5. Of course, that's going to be negative 6 and positive 1. So we have 2x squared minus 6x plus x minus 3. And that would be 2x times x minus 3 plus 1 times x minus 3, which is equal to 2x plus 1 times x minus 3. Moving on to this denominator, we need to multiply to negative 18 and add to negative 7. So that's going to be negative 9 and positive 2. So it would be 3x squared minus 9x plus 2x minus 6. Go ahead and pull out the common factors. It would be 3x times x minus 3 plus 2 times x minus 3. And so that would end up being 3x plus 2 times x minus 3. And then finally over here, if we do the factor x, we need to multiply to 36, add to negative 15. So that would end up being negative 12 and negative 3. So we get 4x squared minus 12x minus 3x plus 9, which equals 4x times x minus 3 times x minus 3. So that equals 4x minus 3 times x minus 3. Oh boy, that was a lot of factoring. However, what do we notice? This denominator has a factor of x minus 3, this denominator has a factor of x minus 3, and this denominator has a factor of x minus 3. Now, our first thought might be, well, in order to get a common denominator, we're going to need to multiply this one by 3x plus 2 and 4x minus 3. We're going to need to multiply this one by 2x plus 1 and 4x minus 3. And we're going to need to multiply this one by 3x plus 2 and 2x plus 1. Therefore, the common denominator would have 4 factors. And now, while you certainly could do that, now you're bordering on the territory of getting into quartics. And given that this is a 4-pointer, that's probably not what MAML intended us to do. So it would be convenient if we could get rid of these extraneous factors and just keep the x minus 3's, and we can if we factor the numerators. So let's go ahead and now factor the numerators. And you'll notice I've been doing factoring by grouping this entire time, but let's go ahead and use our slide and divide method instead. So we would then have x squared plus 5x plus 4. So then it would be x plus 4 times x plus 1. And then we need to divide by the leading coefficient of 2. So it ends up being x plus 4 over 2, and then x plus 1 over 2. And 4 over 2 is not in simplest form. That actually goes to 2. And so that is a factor, x plus 2, and then we need to slide this one back, so it ends up being x plus 2 times 2x plus 1. So you'll notice it has a factor of 2x plus 1, and this has a factor of 2x plus 1, so those will cancel. Now let's go ahead and factor this one up here, and again, let's use our slide and divide method. So it's going to be x squared plus 19x plus 90, and of course that factors to x plus 9 times x plus 10. Now divide by 15 because that's the leading coefficient, and we get x plus 9 over 15 times x plus 10 over 15, and of course those are not in simplest form. 9 over 15 reduces to 3 over 5, and 10 over 15 reduces to 2 over 3. So when we then slide the 5 back and slide the 3 back, we are left with 5x plus 3 times 3x plus 2, and of course the 3x plus 2 is a shared factor, so we'll be able to cancel it. Lastly, let's go ahead and look at the numerator up here. So again, let's use our slide and divide method. So it's going to be x squared plus 7x minus 144. Now we need two numbers that multiply to negative 144 but add to 7. It ends up being x plus 16 times x minus 9. From that point, divide both of these constants by the leading coefficient of 12. So we get x plus 16 over 12 times x minus 9 over 12. Now, of course, 16 over 12 reduces to 4 over 3, and 9 over 12 reduces to 3 over 4. So our final answer, once we slide this 3 and slide this 4, we get 3x plus 4 multiplied by 4x minus 3. And then that shared factor will be the 4x minus 3. Now there is a lot going on here. We have factored 6 quadratics, which is pretty crazy for MAML to ask you to do, but they did. Now let's go ahead and do some massive cancellations. So remember, this is the numerator, this is the denominator, so the 2x plus 1s will cancel, leaving us with x plus 2 over x minus 3. So that's our first fraction. Then we're going to add the next fraction. This one is the numerator, this one's the denominator. The 3x plus 2 cancels, leaving us with 5x plus 3 over x minus 3. And then finally over here, the 4x minus 3 cancels with the 4x minus 3. This is the numerator, this is the denominator. So we're left with minus 3x plus 4 over x minus 3. Now we have a common denominator, finally, of x minus 3. Let's go ahead and add these together. So x plus 5x minus 3x is 3x. 2 plus 3 minus 4 is 1. And then the denominator will stay the same as x minus 3. And that is our final answer. Right, the numerator and the denominator, they don't share any common factors. So this is in simplest form. It's one fraction, and it doesn't have any parentheses. Yes, I know that was a doozy of a problem, especially for only being a 4-pointer, but we got through it. Let's go ahead and move on to our next 4-pointer of this video. All right, now on this problem, we are going to have to remember synthetic division because it will be our friend. Now you could solve this via factoring, but synthetic division will make our lives much easier. I don't like that we have this 32 divided by x, so I'm going to multiply every term by x. Additionally, I noticed that we have a common factor of 8 in every single term, so let's go ahead and divide every single term by 8. So what we're left with is x to the 5th minus 3x to the 4th minus 4x cubed plus 12x squared, and then over x squared minus 4. Now, notice, the x squared minus 4, that's a difference of two squares and can be rewritten as x plus 2 times x minus 2. Now that we have linear factors in the denominator, we can use synthetic division in replacement for polynomial long division, right? Because if this had been a quadratic that we couldn't factor, then we would have to do polynomial long division. But because these are linear factors, we can instead replace that with synthetic division. And remember, the number in the corner that you use for synthetic division, it's whatever number makes this factor 0. So in this instance, it would be -2. In this instance, it would be +2. And so it doesn't matter the order which we do them, so let's start with -2. Now, let's do the synthetic division over here. So we're starting with this factor, x plus 2. So it's going to be the number -2. And we've got to be careful that we include all of the coefficients, including the ones that are not visible. So of course we have 1, -3, -4, and 12. So I'm going to do 1, -3, -4, and +12. But then we also have an x term and a constant term that are just not there. So we need to remember to include them as zeros. 0, 0. So now let's do our synthetic division. We have bring down the 1, multiply -2, -5, multiply the -2, and you get 10. Then you get 6 here, multiply the -2, -12, 0. And then, of course, you then go 0, 0, 0, 0. And because our remainder is 0, that means that this is valid. X plus 2 is a factor of the numerator, so this is good. And now let's continue our synthetic division, this time with 2 as our value, right? Because 2 minus 2 is 0. So 2 is our value now. We can just pick up where we left off. So bring down the 1, multiply by 2, -3, -6, 0, 0, 0, 0, 0. This remainder is also 0, so we're good. X minus 2 is a factor of this, and this is what we're left with. Now, be very careful when interpreting what this means. We have a quintic up here. We're dividing by 2 linear factors. So if we have a 5th degree polynomial and we're dividing by a linear term and then another linear term, we're expecting for a result to be a cubic. And that's exactly what this is. Remember, because this is the constant, this is the linear term, this is the quadratic term, and this is the cubic term. So our final answer is x cubed minus 3x squared. Now in the problem, it says write as a binomial without parentheses. This is a binomial because it has 2 terms and there are no parentheses. Now, you could factor out an x squared and say that it's x squared times x minus 3, but again, that's not what the problem is asking you to do. Additionally, this is just an expression. It's not set equal to anything, so we're not solving for values of x. We will do that later on in this video. Let's go ahead to our final 4-pointer of this video. So this is pretty different from what we've been seeing. This is a word problem. So let's go ahead and read it. In a certain city, a birth occurs on the average every 24 minutes and a death every half hour. A resident moves out of the city every 1.5 hours and a new person moves in every 4.5 hours. How long in hours does it take on average for the population to increase by 1 person? Now, the key to this problem is going to be a rate, because it's giving us change in population and it's giving us time. So that's the perfect setup for a rate. And remember, in almost all cases when we have a rate, we're going to have time in the denominator and our other variable in the numerator. In this case, our variable is people. So let's go ahead and solve this problem, and I'm going to convert those minutes into hours. So 24 minutes. If we divide that by 60, we get 24 over 60, which can be reduced to 2 over 5. And 2 over 5 is 0.4, so this equals 0.4 hours. And then the 30 minutes, of course, that's just half an hour, 0.5 hours. So in this city, a birth occurs on average every 24 minutes. So a birth increases the population by 1 person. So we would say 1p over 0.4h. Then a death every half hour. So we are going to subtract 1 person every 0.5 hours. A person moves out of the city every 1.5 hours. So again, we're going to lose another person every 1.5 hours. And then we're going to gain a person every 4.5 hours. Those are the people who are moving in. So now, in order to combine this rate into one entire rate of change of population, we are going to need to find a common denominator. Now, between 0.4 and 0.5, I would go to 2, because this multiplied by 5, and then this multiplied by 4 gets us 2 in the denominator. And then between 2 and 1.5, I would go to 6, because 2 times 3 is 6, and 1.5 times 4 is 6. And then finally, between 6 and 4.5, I would go to 18, because 6 times 3 is 18, and 4.5 times 4 is 18. That's the common denominator then. Our common denominator is 18. So let's go ahead and change all of these to reflect that common denominator of 18. So to get from 0.4 to 18, we're going to multiply by 45. So this is going to become 45 people over 18 hours. Then we are going to subtract, and this would become 36 people over 18 hours. Now this one would become minus 12 people over 18 hours. And this term would end up being 4 people, plus 4 people every 18 hours. So now that we have a common denominator, all we need to do is add the numerators. So 45 minus 36 is 9, minus 12 is negative 3, plus 4 is positive 1. So our total combined rate is that we have 1 person every 18 hours. So in terms of the context of this problem, this means that we are gaining 1 person in the population every 18 hours. And so now let's go ahead and take a look at what the question was asking. How long in hours does it take on average for the population to increase by 1 person? This rate answers our question. 1 person every 18 hours. So our answer in hours is 18. The toughest part about these word problems is taking what they're giving you in words and transferring them into equations. That's the hardest part. Solving the equations, sure, you could have made an arithmetic mistake, but that's pretty easy. The hardest part is interpreting the information they're giving you and transferring that into solvable equations. So we'll have one more word problem. It'll actually be the last problem of this video. So I recommend before I go ahead and start explaining that, just try to set up some equations that you think might work, and then you can go ahead and follow the rest of my work and see if we use the same equations or maybe slightly different equations. But that's for problem 9. For now, let's move on to problem 7 of this video. Alright, here's our first 5-pointer of the video, and it tells us to find all real values of x such that 1 over x squared minus x squared over 1 over x plus x equals 3 over 2. This is the first time where we'll actually be solving for values of x, so that's important. Now, normally when we have this situation where we have something over something equals something over something, I would advise you to cross multiply as your first step. That would be cross multiplying as your first step. However, in this problem, we actually don't want to do that because we notice that the numerator is easily factorable. And that's because it is the difference of 2 squares. So we have 1 over x squared minus x squared. Now, as a difference of 2 squares, that would equal 1 over x plus x times 1 over x minus x. This is the setup for our difference of 2 squares, right? A squared minus b squared is equal to a plus b times a minus b. So now that we have that, we can rewrite the left side of this equation to be 1 over x plus x times 1 over x minus x over 1 over x plus x. And now notice that this factor is equal to the denominator, so that cancels, leaving us with 1 over x minus x equals 3 over 2. Now let's go ahead and multiply everything by x. So we get that 1 minus x squared is equal to 3 over 2x. And because I don't like this fractional coefficient, let's go ahead and multiply everything by 2. So we get that 2 minus 2x squared is equal to 3x. And now getting everything over to that right side, we would say that 0 is equal to 2x squared plus 3x minus 2. From this point, you could use either method, factoring by grouping or slide and divide to solve. Let's go ahead and use slide and divide. So we will say that x squared plus 3x minus 4 is our new quadratic that we are factoring. From that point, two numbers that multiply to negative 4 add to 3. That would be x plus 4, x minus 1. Remember that we got to divide by our original leading coefficient, and we got to divide the constant terms by that, so it becomes x plus 4 divided by 2, which is just 2, times x minus 1 over 2, and then we slide as our final step, so this becomes x plus 2 times 2x minus 1. So therefore, the two values of x that would make this equal to 0 would be when x plus 2 equals 0, so x is negative 2, or when 2x minus 1 is equal to 0, which means x is 1/2. So our final answer is negative 2 or 1/2. So now, even though this is our final answer, we have to make sure to check the denominator to make sure that we're not dividing by anything we can't. And that essentially means we can't divide by 0. So checking, if we plug in -2, we get 1 over -2 plus -2, so that's -1/2 minus 2, which is certainly not 0, it's -5 over 2. And then if we plug in 1/2, we get that 1 over 1/2, which is 2, plus 1/2, so we get 2 plus 1 over 2, which is 5 over 2. So with these values of x, we get that the denominator is either -5 over 2 or +5 over 2, which neither of those are 0, and therefore we are good. We are not dividing by 0, so therefore both of these values of x are valid. But remember, in these types of problems, to always check that we're not dividing by 0. Alright, let's go ahead and move on to the 8th problem of this video. Alright, and we have another problem where we're solving for x. So in this case, we have a left side, we have a right side. What we're going to want to do is get common denominators on one side and common denominators on the other side, and then from that point we can cross multiply. So let's go ahead and on the left side get common denominators. So I'm just going to multiply this one by x over x and multiply this one by 3 over 3. So we've got x squared over 3x minus 3x minus 9 over 3x. And that ends up being x squared minus 3x plus 9 because it's minus 9, so it's plus 9. So together this would be x squared minus 3x plus 9 over 3x. So on this side, to get the common denominator, we're going to multiply this by 2x over 2x and this one by x plus 3 over x plus 3. So we get that 2x squared minus 6x over 2x squared plus 6x, and then we add this fraction, which ends up being x plus 3 times x plus 3, which is x squared plus 6x plus 9, and on bottom we have the same denominator, 2x squared plus 6x. And so when we add these fractions together, we get 2x squared plus x squared, which is 3x squared. The negative 6x and the positive 6x go away, they cancel out. Then we have a plus 9, and then we're dividing that by 2x squared plus 6x. Now that we found common denominators on the left and the right side, let's go ahead and rewrite our equality as x squared minus 3x plus 9 over 3x equals 3x squared plus 9 over 2x squared plus 6x. Now, what you'll notice is that on the denominators, we could factor out an x from both of them. So technically, this is 3 times x, and this one is 2x plus 6 times x. And so if we multiply both sides by x, that would end up getting rid of that shared factor. So we can actually just get rid of that shared factor. So on bottom, this ends up just being 3, and on bottom, this just ends up being 2x plus 6. That makes our lives a lot easier when cross-multiplying. So now let's cross-multiply. We get that x squared minus 3x plus 9 times 2x plus 6 is equal to 3 times 3x squared plus 9. Go ahead and distribute this out. Let's start with the 2x and distribute that out to all of these. So it ends up being 2x cubed minus 6x squared plus 18x, and then do the 6. So plus 6x squared minus 18x plus 54. Conveniently, these cancel out, leaving us with 2x cubed plus 54. And that equals, on this side, when we distribute, it's 9x squared plus 27. So getting everything to one side, let's get everything over here. So we find that 2x cubed minus 9x squared plus 27 equals 0. So now we have a cubic equation, and of course, to solve for the cubic equation, we can use synthetic division. Now remember our rational root theorem, which would be all of the factors of 27 over all of the factors of 2. If you wanted to write that out, you could. I'm just going to test what seems like the most obvious one, which would be 3. Okay, so let's see if 3 works, right? Because 3 is a factor of 27, so let's test it out. So when we do synthetic division, we get 3, 2, negative 9. Don't forget the 0. There's no x term, so we need to have a placeholder 0, and then 27. And when we do synthetic division out, we drag down the 2, multiplied by 3 to get 6, get negative 3 here, negative 9 here, negative 9 here, negative 27 here, and a 0. So that is a factor that is, in fact, one of our answers, x equals 3. Now we have the quadratic 2x squared minus 3x minus 9. And if we were to factor that one, which we can do up here, we can do the slide and divide method. We get x squared minus 3x minus 18. And then that becomes x minus 6 times x plus 3. And then divide by your original leading coefficient, which is 2. So you get that it's x minus 6 over 2, which is just 3. And then x plus 3 over 2. And then if we slide that 2 over, it becomes 2x plus 3. That's the factored form. So we've already found that one of the factors is x minus 3, right? This factor right here is x minus 3. And then we found that the other two factors are another x minus 3 and 2x plus 3. So these are our three factors, and remember, they're set equal to 0. So what we can say is that these three factors, x minus 3 and then squared, and 2x plus 3 equals 0. So therefore here, x would be 3. Here, x would be negative 3 over 2, and those are our final answers. Now remember, you should always go back and check to make sure that you're not dividing by 0. So here, there's no worries. Here, we would be dividing by 0 if x were 0, but x is not 0, so we're good. Here, we would be dividing by 0 if x is negative 3, but x is not negative 3, so we're good. And then here, we would be dividing by 0 if x were 0, but x is not 0, so we're good. So our answers are 3 or negative 3 over 2, and those are valid. So let's go ahead and jump into our last problem of this video, which remember is that word problem that I mentioned back in the 6th question of this video. So without further ado, let's get into that question. All right, an experienced plumber made $800 for working on a certain job. His apprentice, who makes $5 less per hour, also made $800. However, the apprentice worked 8 hours more than the plumber. How much does the plumber make per hour? Now, the key to solving this one, like the last one, is rates. Now, specifically, in this question, we need to recognize that the rate is dollars per hour, right? We're solving how much he makes per hour, which is going to be in dollars per hour. And then if we have dollars per hour and we multiply that by hours, the hours are going to cancel, leaving us with dollars. So the key equation here is that rate multiplied by time equals money. So I'll just write that up here in all caps. So now we have to define some variables. We are solving for the plumber's hourly wage, so we're going to represent that as a rate, which is R. So R is equal to money per hour plumber makes. Then we are going to write T as the amount of time plumber works. And remember, rate times time equals money, and therefore the plumber's rate times the amount of time he works is equal to $800. He made $800. So RT equals $800. Now his apprentice, we have to take into account the modified rate and the modified time. So it tells us the rate is $5 less per hour and the time is 8 more hours. So R will instead be R minus 5. T will instead now be T plus 8, and yet the dollar amount remains the same. He also made $800. Now because these are the same amounts of money, $800 and $800, we can say that the left sides of these equations are also the same. They must be equal to one another. So we can say that RT is equal to R minus 5 times T plus 8. Now let's distribute this one. We get that RT is equal to RT plus 8R minus 5T minus 40. And of course, we have RTs on both sides, so they cancel, leaving us with 0 is equal to 8R minus 5T minus 40. Now, taking a look at this equation up here, we want to solve for R. Therefore, it would be very convenient if we could express T in terms of R. So that's what I'm going to attempt to do here. Let's add the 5T to both sides, so we get that 5T is equal to 8R minus 40. And then divide both sides by 5, and we get that t is equal to 8r minus 40 over 5. So we can replace this t with 8r minus 40 over 5. So let's go ahead and do that. We can say that r times 8r minus 40 divided by 5 is equal to 800. Now multiply both sides by 5. We get that r times 8r minus 40 is equal to 4,000. These have a common factor of 8, so let's divide 8 from both sides, and we get that r times r minus 5 is equal to 500. Now it's just a quadratic that we can solve. Distributing this, we get that r squared minus 5r would equal 500, so let's subtract that 500 to this side, and that equals 0. Now the question is, we need two numbers that multiply to negative 500 and add to negative 5. So go ahead and ponder that for a moment. The correct answer is negative 25 and positive 20. So for r, we can factor this, and we're running out of room, but I think there's enough here. It ends up being r minus 25 times r plus 20 equals 0. So your two solutions for r are 25 or negative 20. Now, the only one that makes sense is the positive answer, right? It only makes sense if the answer is that he makes $25 an hour. If it were negative 20, that means he's making negative $20 an hour, which means he's paying people to do the job, which doesn't make any sense. It makes sense that he's earning money, so therefore it must be positive, and therefore the answer must be $25 an hour. So our final answer we can write over here is 25, and if you wanted to include the units, you could. Just make sure that they are the correct units, which are $25 per hour, or you could just do the dollar sign divided by hour. With this tricky word problem out of the way, that concludes this video on algebraic fractions with factoring. This was our video on 9 problems from Meet number 5, topic number 1, algebraic fractions with factoring.
Thank you for watching.
I'm Sebastian.
And I'm Iris.
And we're the MAML Manual.